Okay, now we have a problem from 11.2 having to do with the present value formula. So this is number 24 on page 642. And up to now, we have been calculating the maturity value or the final value of an investment after a number of years or months, time period, at a certain rate, compounded for a certain number of times per year. So recall this formula here was what we were working with. Well, now all we're doing is solving this formula for the original amount. We want the present value. We want to know how much do we need to invest to end up with a certain amount after a certain amount of time, compounded a certain number of times per year. So all we're doing here is we're just solving this equation for P. So if we think about how we solve an equation, we know if we divide this side by this same thing here, then they just cancel out and we're left with P. Well, I have to do that to the other side also. Right? If I divide both sides by that, well, this cancels out. This is just the number 1. So I'm left with the P. And now I have this as my formula, which is this. Right? Whenever you have something raised to a positive exponent in a denominator, you can bring that up to the numerator and make it a negative. Remember this rule, right? Anything raised to a negative exponent is 1 over that thing raised to the positive exponent. We learned this in chapter 10 when we were talking about exponential functions, right? Exponents, rules of exponents. So all we did was start with the original formula and we solved for P to get this formula. So this is the formula we're using to find how much we need to invest to end up with a final amount. Notice the negative exponent there is the only real difference. Okay. So let's use this formula to answer this question. So we want to end up with $10,000 after 30 years with an interest rate of 4% compounded semi-annually. So we have the A, we have the R, we have the N, and we have the T. We have everything we need. So all we have to do is plug into the formula and say 10,000 times 1 plus the rate as a decimal, right? 0.04 over 2. Semi-annually is 2. And is 2. And now we're raising to the negative NT. So N times T is 60. So that's what we're doing now. Let's go to the calculator and see what we get. It's our handy dandy calculator. Let's turn this buddy on, clear the screen. And we calculate this just like we did the previous one. The only difference again is the negative exponent. So we're going to start with the inside the parentheses and say the rate divided by n of 2 and get a result. We're going to add 1 to that. Now we have what's inside the parentheses. We're raising that to a negative. Use this for negative. This is subtraction. This is for negative numbers. Negative 60. You can put that in parentheses if you'd like. It's always smart. I don't think we absolutely need it here, but we raise that. And now we're going to multiply that by that final amount that we want to have. And this tells us how much we need to invest. So in this case, we need to invest $3,047.82 if we want to end up with $10,000 after 30 years. We want to end up with $10,000 after 30 years at 4% semi-annually. We calculate using the present value formula, and we get our
answer of $3,047.82. So that is how much we need to invest to get $10,000 after 30 years. So that is the present value formula.